When working on problems dealing with interior and exterior angles of polygons, it's important to read the problem completely. You want to be able to identify whether they're talking about interior versus exterior, whether the polygon is regular or not regular, and whether they're talking about the sum of those angles or each angle. In this video, we'll look at when they're asking about each exterior angle and each interior angle. First, this problem tells us that each exterior angle of the regular polygon is 30 degrees. It's important to remember that the sum of the exterior angles is always 360 degrees. Because it's a regular polygon, each exterior angle will be exactly the same measure, and they will add up to 360 degrees. So if you take your 360 degrees, divide by the number of sides, n, it will equal each interior angle, which in this case is 30 degrees. From here it becomes an algebra problem. Since n is in the denominator, we can't simply multiply by 360, because that's the numerator. Two-step process here would be to first multiply both sides by n. That would leave you 360 degrees on the left-hand side, and leave you 30n on the right-hand side. Second step would be divide by 30 on both sides, and it would tell you that n is equal to 12. We had already defined n as the number of sides, so this would be a 12-sided regular polygon, or a regular dodecagon. In this second problem, they tell you that each interior angle of a regular polygon is 135 degrees. So we have to remember that the sum of the interior angles of a polygon is 180 degrees times the number of sides minus 2. And if I want to find each interior, I would then divide that by the number of sides. We can only do that if it is a regular polygon, just like it is here. And that would equal each interior angle. We can substitute in all the information we know. We don't know n, but we do know each interior. So I could say that 180 times n minus 2 all over n is equal to the 135 degrees, and I'm solving for n, which will then tell me how many sides this polygon has. First step is similar. I'm going to multiply both sides by n. I want to get rid of my fraction. I have 180n, if I distribute at the same time here, minus 360 equals 135n. Use my algebra skills. Subtract 180n from both sides. I'm left with negative 360 equals negative 45n. Then I divide both sides by the negative 45. Negative divided by a negative is a positive, and n equals 8. That tells me this polygon is an 8-sided regular polygon, or a regular octagon.